Okay, so we have, this is just a summary of what I said. So we have that square root of n times x bar minus mu over s has this t distribution. Okay, and that's when we're sampling from a normal mu sigma squared distribution, but we don't know, or well, if we don't know sigma squared, I mean, even if we know sigma squared, this is true, this statement is true, but if we don't know sigma squared, that's why we would create a function like that. Yep.
So when in the case when I cannot sample a large n and I'm forced to sample a small sample.
Yeah, if you could speak up just a little bit.
If I'm forced to sample a small
yeah,
size.
You have a small sample.
And that means that the smaller my sample, let's say the smaller my confidence, the larger my confidence interval would be, obviously, right?
Yep.
So my question is, I know sometimes a small sample is not representative of the population, but sometimes it's okay. My question is, what is the cutoff confidence interval in everyday research and experiments where it's okay for me? Is it okay for me to say, well, I'm 20% confident interval, 20% sure that my sample is representative? That's obviously not, but is 80 okay?
So you've asked kind of a question that has a number of pretty subtle answers to it. So there's a lot of things going on in your question. So in case people didn't hear, the question was, how large does your sample have to be before you have sort of a reasonable amount of confidence that the sort of estimates that you're deriving from the sample are reasonable? Is that a fair statement? So there's a lot of things going on. So first of all, we're going to assume in this class, for the most part, that your sample is randomly drawn. And sometimes you might have a situation where you have a sample, but it hasn't been randomly drawn. And that sort of complicates the analysis. So when we talk about small samples, they're still going to be, quote, representative. They're still going to be, randomly drawn from the population. We're assuming that. But when they're small, it just means that our estimates, we don't have very much confidence in our estimates. And that's going to be exhibited in how large our confidence intervals and how big the standard error of our estimate is. And there's nothing wrong with that. We're just, you just say, look, I'm estimating this unknown parameter, but I don't have very many observations, so my estimates aren't very precise. I'm not very sure of them. And that's why we want to quantify how sort of confident we are in our estimates by doing things like creating confidence intervals.
I guess my question comes from a publication point of view. Like, is it okay for me to publish something where I'm 80% sure? Or
So your referees would be the ones to tell you whether it's okay to publish that. And it just depends. I mean, there are some cases where it's relatively easy to get much larger samples, and then referees would typically tell an author, you should go out and get a much bigger sample and produce estimates you're more confident in. And there are some cases where maybe it's impossible to get a larger sample, and the evidence that you have is the best out there, even if it's not that good. So so there's sort of different ways to answer your question. There's no right answer. There's no, I can't tell you an n, a magic n that you always need to have. Okay, does anyone know the origin of the t distribution? Okay. The t distribution was actually formulated by William Seeley Gossett in his job as chief brewer in the Guinness Brewery in Dublin. So I went to the Guinness Brewery with my family a couple years ago, took a photo of this plaque that's right on the wall of the brewery. And basically he derived and tabulated this distribution to aid in his analysis of data for quality control across batches of beer. Okay, so he had a relatively small number of batches of beer. He didn't know what the variance that he, of the distribution he was sampling from was, and so he was the one who actually formulated and tabulated, or derived and tabulated this distribution. And if you go to the Guinness factory, seek out this plaque, and you can have your picture taken and buy it and like email it to me or something. Yeah.
Every time this is students T-distribution, I always thought this was just a simplified version of the T-distribution.
Nope, totally not. That's the T-distribution. And it was, yeah, so he published his paper, I think it was in Biometrica, under the name student, because I guess even though the Guinness Brewery was supportive of his efforts, they didn't want, I don't know, they didn't want it known that their chief brewer was publishing, papers in mathematical statistics or something, so I don't know.